Okay, today we are just doing a review lesson on finding rate of change or slope from both a graph and from a table. So it should be fresh in our mind from a graph, but it's been a little bit since we've done tables, so we'll go through some vocab before we answer those questions. So let's start with from a graph. Okay, so if we are trying to find the slope from the graph, we're going to find 2 points that fall on a grid line intersection. So I'm going to pick that point right there at 0, 2, and then I'm going to pick another one. It looks like it's 2, 8 right there. Okay, and then I'm just going to kind of create my rise and run, which makes what we call like a slope triangle. And really when you're finding the rise, you are just finding the length of that vertical side, so how far up you're going. And then when you're finding your run, you're looking at how far right you're going, and then we find the ratio of those two numbers. Okay, so if I look at my graph, if I look at this vertical side of my triangle, the length of that is 1, 2, 3, 4, 5, 6 blocks. Okay, so 6 would be the length of that side, and that is also my rise. Then if I look at my horizontal side of the triangle, which is my run, that's 1, 2 is the length on that. Okay, so if I go to find my slope or my rate, the rate is the rise divided by the run, so 6 divided by 2 gives me 3. And we're just going to be using that same strategy for finding the rate from any graph. Okay, so let's look at this first graph. This is a motion graph for Terrence and the skateboard. So he's skateboarding. There's a motion detector that's tracking his movement. So question A says, segment blank shows a rate of 0 feet per second. Okay, so if we have 0 feet per second, we're not moving, right? There's no movement. So if we look at these 3 pieces, B is the section that indicates that Terrence is stopped, right? A horizontal line means that he's stopped. And if you look at that, time is going on, but there's no vertical change. So there's no change in distance. So segment B is where Terrence is stopped, and that is a rate of 0. Okay, segment blank shows a negative rate of change. Well, we read our graph just like we read a book or a sentence. The same way that we write a sentence, we write from left to right. So we read our graph from left to right. Segment A is decreasing from left to right. So it shows a negative rate of change. Similarly, we can look at segment C. Segment C from left to right is going up the page. So that means there is a positive rate of change for segment C. Okay, so now we're being asked to find the rate, the actual rate for segment A. So I'm going to go in and I'm going to draw my slope triangle in here. So you could use any 2 points on the graph. So I could use this point and this point, as long as they're on an intersection of a grid line, because we want to be precise. We don't want to be guessing what our rate of change is. We want to be precise. Okay, so I'm going to draw in my triangle, and then I want to find the lengths of both sides. So the vertical change, or my fall, is 2, length 2, takes up 2 blocks. So -2 is my fall. And then my run is just 1, takes up one block. Okay, so when I go to find that rate, the rate is going to be the fall over the run. So I have -2 over 1, which gives me a rate of -2 feet per second. Okay, we're going to go back up here. We're asked to find the rate of change for segment C now. So I'm going to look at this and see where I have points that are on an intersection. So the first one, and see now this one is close, but we want to be precise. So I'm not going to pick that one because it's not exactly on a grid intersection. I'm going to choose the last one because it's clear to me that that's at 10.3. I'm going to draw in my slope triangle, my rise, and my run, and then I'm going to find the measurements. So the vertical side, I'm rising 1, 2 blocks, and I'm running 1, 2, 3, 4, 5. Okay, so I just take the ratio of those two. Okay, the rate would be 2/5. And since that's a fraction that can't be reduced, I'm just going to leave it that way. Okay. And you're going to want to leave your slope in fraction form. Trust me, when we get into more graphing next semester, like you're going to want to see a fraction instead of a decimal. It just makes life easier. Okay. So that is all of the problems in the lesson where we're looking at a graph to find rate. So we have one where we're going to review finding it from a table. So I'm going to go back up to my vocab, and I am going to recall that when I'm finding the rate, I'm looking at the change in y divided by the change in x. So when I'm looking at a table, I am looking to see what is happening between these values. So how is my y column changing? How is my x column changing? Okay, if I look at my y column, I go from $67.50 to $75. Okay, and you may certainly use a calculator, but we're adding $7.50 between those two numbers. And it's important that you put a sign there so that we know that we're adding and not subtracting. And then I'm going to look over at my x column, and from 6 to 8, I'm increasing by 2. So when I go to find my slope, I take 7.5, I divide it by 2, and my rate is 375 per class. And we want to make sure that we have our units because we're talking about total cost per number of classes, so 375 per class. Okay. All right, so we have a table now that's demonstrating Terrence's movement. So we're going to go through that same process. We're going to look at our change in y. How are these numbers changing? 2, 4, 6, 8. Well, we're adding 2 between all of them. And we're going to go and look at our change in y. 0, 1, 2, 3. We're adding 1. So when I go to find my rate is the change in y over the change in x. So I take 2 divided by 1, which gives me 2, and let's put a unit on that, 2 feet per second. And we're done.